Here we have the graphs for the normal distribution with the mean mu is equal 0 hold constant, while we vary in the standard deviation sigma. So higher sigma has wider spread. As the standard deviation increases, the curve becomes flatter and wider. So this is evident from the transition from the curve sigma is equal 0.5 to the curve sigma is equal 3. The higher the sigma, the more spread out of this distribution it is, which indicating a higher dispersion of the data around the mean. So conversely, lower sigma, narrower spread. So a smaller sigma results in a taller, narrower curve. This indicates that the data points are more tightly clustered around the mean. Let's talk about the probability density. Sigma is equal to 0.5. The probability density is higher near the mean and drops off more steeply than the larger sigma values. So this shows how that data are very likely to be found close to the mean. At larger sigma values, for example, when sigma is equal to 3, the probability density near the mean is very low, but the tails are heavier. So this indicating a higher probability of finding values farther than from the mean. Let's talk about the implications in data analysis. So a larger sigma reflects more variability in data. For instance, if these curves represent test scores, a larger sigma suggests they have diverse student performance, and a smaller sigma suggests that most data points are similar to each other, which is indicative of uniform performance or characteristic in the context of the data being analyzed. So these differences are crucial for statistical analysis, which are affecting predictions and confidence in estimates. And these interpretations of data spread. So if you are analyzing data and need to choose a normal distribution as a model, so selecting the appropriate sigma values can dramatically affect your conclusions and the effectiveness of your statistical tests. We have 3 normal distributions here, and each of them with a different mean mu, while keeping the standard deviation sigma constant at 1. And we have a normal distribution which is characterized by the mean mu and standard deviation sigma. So the mean mu determines the center of this distribution, while the standard deviation sigma controls the spread or width of this bell curve. Let's check out different means mu. When mu is equal to -3, this distribution is centered at -3, so the peak of this curve is shifted to the left. And when mu is equal to 0, this distribution is centered at 0, which is the standard normal distribution where the curve is centered at the origin. And when mu is positive 3, this distribution is centered at 3, and the peak of this curve is shifted to the right. This visual comparison highlights how the mean affects the position of a normal distribution on the x-axis. So changing the mean mu shifts the entire distribution along the x-axis without altering its shape, and each distribution remains symmetric around the respective mean.